Alright, so here is the parabola section. Remember, there's two sections. There's section 10.2 and section 3.3 for parabolas. Now, this is the ones you were supposed to watch the video for, so please see the earlier file folders for those if you're interested. Now, remember, generally when we think of a quadratic equation, it is something of the effect ax squared plus bx plus c. Now, as we said before, there are many forms in which to write the equation of a line. The same holds true for the equation of parabolas. So your author and I are going to refer to standard form for a parabola to be of the form f of x equals a times x minus h squared plus k. This then gives us information about the vertex. The vertex then is going to be change the sign just like we did for an ellipse, a circle, and a hyperbola for the h, but the y value, the k, is going to remain the same. All right, so let's go ahead then. I want to take a look at an example. I want to look at f of x equals then a negative 3x squared plus 3x minus 2. Okay, and we want to go ahead and analyze this function. So I want to know where is it open up or down? I want to know its vertex, x and y intercepts, axis of symmetry, and domain, range, all that fun jazz. Okay. So first thing we got to do is put this bad boy then into standard form, okay? Now to do that, I'm going to have to utilize completing the square. I strongly suggest if you haven't watched those videos yet, please go back and do watch those videos for completing the square. So I'm going to move that constant term, that negative 2, over to the other side by adding 2 to both sides. So f of x then plus 2 equals a negative 3x squared plus 3x. Now to complete the square, the leading coefficient has to be a positive 1. So to accomplish that then, I'm going to go ahead and I'm going to factor out a negative 3 to give me then x squared minus x. Now I'm going to leave myself a little bit of space here. Okay. Now we want to complete the square. So to do that then, we're going to utilize the aside. Now remember, my aside is going to be b over 2. We're going to square that. b in this instance is going to be that negative 1. Square it to give me then a magic number of 1/4. So I'm going to add 1/4 to this side to complete that. But remember, we're not really adding 1/4. We're adding 1/4 times a negative 3, which is a negative 3/4. So we're really adding then a negative 3/4 to both sides. So I need to add then that negative 3/4 to the left-hand side as well. Now again, the whole purpose of completing a square is to make then that right-hand side factorable. So that's going to become then, my apologies, become then a negative 3 times, this will then factor into x minus 1/2 squared. Over here, 2 minus 3/4, 2 is the same thing as 8 over 4. So 8 over 4 minus then 3 over 4 is going to be a hand bump, will be then plus 5/4. All right. Now to get this thing back completely into standard form, we're going to subtract that 5/4 over to the other side. Woo! All right, and there we go. Now we are in standard form officially. Now that we're in standard form, we can go ahead, we can talk then about the domain. Since it is a parabola, its domain is going to be all real numbers, so negative infinity to infinity. We can then go ahead and talk about the range, which we will in a minute, but before we even begin that, I want to look then at my vertex. My vertex, the whole purpose of putting this then into standard form. My vertex then is going to be the point 1/2, negative 5/4. Notice the x-coordinate changes, but the y does not in this instance. Now, as we look back then, since this is a negative. A is negative. That means that the graph is going to open down. Okay? So that means that my range is going to go from negative infinity all the way up then to my y-coordinate, because again, the range is the y. Since we're including it, it's going to get a bracket. So now I have my domain, I have my range. So now let's go ahead, okay? Let's then talk then about our x and y intercepts, okay? Now, the y-intercept I always find easier because all you have to do is set x equals 0. I like to plug it into the original equation just because it's generally quicker. Not always, but generally. So I have then my y-intercept of 0, negative 2, okay? To find then my x-intercept, we set y equals 0. Now for me personally, I like to use the standard form only because it becomes a little bit easier then to use extraction of roots technique. All right, I'm going to add that 5/4 over to the other side. Divided then by a negative 3. And then taking the square root of both sides. However, as we notice here, we're taking the square root of a negative number. Since we are taking a square root of a negative number, we know that that is going to be an imaginary number. And since it's going to be an imaginary number, that means then there are no x-intercepts. Okay, so there are no x-intercepts. All right. Now, we can also then go ahead and talk a little bit about the axis of symmetry. When we look at the axis of symmetry, remember, this is the vertical line that goes through the vertex, and the one side of the parabola is symmetric to the other side. So that's going to be then just simply x equals through the x-coordinate of our vertex, which I got to scroll back up here because I don't remember where our vertex was. Oh, there it is, 1/2. So my axis of symmetry then is x equals 1/2. All right, let me run through my checklist here. Let's see. We know the graph is opening downwards. We got the x and y intercepts. We got the domain. We got the range. Okay, I think that's everything. So now all we have left to do then is to go ahead and graph this. So we said then we had a vertex of what was our vertex? I can't remember this. Why can't I remember? All right, our vertex was 1/2 negative 5/4. Okay, so let's adjust our scale. Why am I positive 1/2? I'm losing it. Okay, so here we go. Okay, all right, perfect. Okay, let's get that screenshot going. Okay, so in looking at this then, plotting my vertex, 1/2 negative 5/4 is going to be right there, okay? Now, as we then take a look at this, we also know that we have an x-intercept or y-intercept of 0, negative 2. Now, since this point is 2 units over to the left, we can move then 2 units over then to the right. Not 2 units, a 1/2 unit over. So 1/2 unit then this way. And of course, if you want more points to be more accurate, you can always plug it into the original function. And then, of course, playing everybody's favorite game of connect the dots. And then drawing your nice parabola. Okay? So there we go. All right, that is graphing a parabola. So I hope this helps. All right? Please, again, as always, email me with any questions you have.